Hey, what's going on, guys? It is Solution Day, and as usual, a great week, great answers, great discussions. Today, I wanted to bring up a topic that's been the burning discussion for quite some time, and things like just how important is mental math? I mean, how quickly do you expect to get your answers mentally? And the whole internet is just flooded with a bunch of tips and tricks trying to get your answers quickly and mentally. Now, I'll give you a secret that it's a complete hocus pocus. Mental math isn't as effective as you think it is in testing and your performance. You want to be consistent, you want to be accurate. Speed just is a byproduct of consistency and accuracy. Some people want to be quick in their mental math, but it's a party trick. You don't want to sound smart. You want to be smart, and that's the difference that I tell a lot of my students. That you don't want to sound smart. You want to be smart, because people who spend just so much time trying to learn mental math tricks, it's quite obvious, and even in schools, my 7-year-old daughter. They're telling them that, hey, 19 minus 7 should be thought of at 20 minus 10 plus 2. Okay, well, it's not as effective as you think it is. And learning a whole bunch of funky tricks to do, it's good to learn place values, but you want to be consistent with your math. You don't want to just sound smart. You want to be smart. Now, I have people who can do 5-digit multiplications in their heads, and when you give them a question, something like this, where just numerical smartness, a party tricks, this will separate a party trick with somebody who is truly knows their stuff, and they've got conceptual smartness. Now, it doesn't mean mental tricks aren't helpful. Some things you want to learn, you go back to the basics. You want to learn your multiplication table up to 20 times 20. It's 400 flashcards. You don't even need to make 400 flashcards. Just make what you don't know, like 15 and up is not as common. A lot of people just know their tables by heart. You should, when it comes to mental tricks, consistency is extremely, extremely important. You want to be quick. You'll be surprised how quickly, if you're good with your rough work, how quickly you can get your answers. So learn the tables. Like, you want to learn what's 13 times 5 is instantly. Things like that, 19 times 7. So let's just give a small example. Let's just say, when it comes to number 1678 multiplied by 1319. Okay. So 19 times 8 is 152. So 15 here. 19 times 7 is 133. 133 plus 15, 148. So 8 here, 14 here. So this comes with practice. If you understand your double-digit tables and your addition is strong, you can do bigger number calculations by splitting them into double digits. Okay, so 19 times 6, 114. So 4 goes here. 114, and then plus 14, so 128. Okay, so 128, so 12 here. Okay, so 19 times 1, 19 plus 12, 31. Okay, so that's your first row. Second row, you get about 2 x's. Okay, 13 times 8, 104. 0 here, sorry, 4 here, and 10 here. Okay. 13 times 7 is 91. 91 plus 10, 101. So then 1 goes here, 10 goes here. Okay. Now 13 times 6, 78. 78 plus 10, 88. 8 goes here, 8 goes here. 13 times 1, 13 plus 8, 21. 21. So you add these up, 2, 8, 12, 3, 2. So 2, 1, 2, 3, 2, 8, 2. That's your answer. So you split that up, and you did that by the multiplication tables. And that's why knowing multiplication tables is a very, very handy tip for consistency. If you're good with your rough work, this procedure will take less than 15 to 20 seconds, even on the most complex problems. So instead of going around learning weird mental tricks, you just want to be good with your basics. If you want to have 13 plus 18, you should instantly know that that's 31. You don't want to be like, oh, what's that? You want to have that stuff, basics done quickly. And then you want to learn your multiplication tables up to 20. So then the more you know, the more confident you will be. So mental math is pretty much, the tips and tricks are useless when it comes to actual application of it. Like I said, you don't want to sound smart, you want to be smart. So anyway, so the popular question of the week was the stat question. The question with mean and medians. And this is an interesting question, and only one student got it correct. But it is tricky, and it's quite common in your SATs. So to get a median, you want to look at how many students are there. In a classroom, age and years of the students and number of students plotted on a bar graph as shown. Based on the above information, please answer the following questions. At most, how many students of age 16 years may be added to the classroom so the median age of the classroom does not change? So how many students are there in the classroom? Okay, we've got 10 students of 12 years, 6 students of 13 years old, then 10 14-year-olds, 3 15-year-olds. So how much is that? 10 plus 6, 16. 16 plus 6? 6? No. 10, 6, 10, 26. 26 plus 3, 29. So you've got 29 students in here. So when you have 29, your median, you've got 14 before the median, and that's your median. That will be the 15th. 15th will be your median, and then 14 after that. So the 15th student is the 13-year-old. Okay, so you've got 10 12-year-olds and 6 13-year-olds. So the 15th student is a 13-year-old. Okay, so 13-year-old. So that's your current median, 13 year. Now, what if I add 16-year-olds? Okay, what will the median be, and how much room do I have to work with? Let's say we add one more. Okay, one more. Now we have 30 students. So 30 students, the median would be combination, the average of 15, 16, and then 14 after that. Okay, so the average age of 15th and the 16th student will be the median, which in this case is still a 13-year-old, because in your graph you've got 10 students, 12-year-olds, then you've got 6 students that are 13-year-olds, so 16, and it is arranged in increasing order. That part is already done for you. So the median doesn't change. Okay, now let's just say we had 31 students now, one more added. 31, okay, 15 before, 16th student will be the median, and then 15 after that. So who is the 16th student? It's still a 13-year-old, still in the same bar graph. Your median doesn't change. So we added 1 and 2 students in 16-year-old bracket, and the median didn't change. If we add one more, what will happen if we add one more? 32 students, okay? Now for 32 students, all of a sudden, the median will shift from this to the average of 16th, 17th, and then 15th, 15 after that. So the 16th student and the 17th student. Now the 17th student is now a 14-year-old. So we can't add more than 2. So your answer here is we can add 2 more 16-year-olds and the median is still 13. Your median is 13-year-old. Doesn't change. Okay. So if 3 students of age 16 years were added, so that's our case. So we added. Obviously the mean is going to change. That's a given. The mean will change. The standard deviation would increase because it's more spaced apart. You're adding a larger number, so the deviation from the mean would be, the variance will be larger. So your standard deviation increases because they're more spread out. The median increases as well because we just saw that the median, when there's 32 students now, the median will be 13 plus 14 divided by 2, so 13.5. So median increases. So in our case, we have 1, 3, and 4 as our answer. So I hope that was clear enough. And if you have any questions, please let me know. Message Warma Schooling. Thanks for watching. Bye-bye.